In this lesson, we're going to be talking about quadratic area applications. This is just a continuation of the previous lessons, how to set up these equations and how to solve them. The first example, our only example of this lesson, a rectangular cotton field is to be enclosed by a fence alongside a river. The river serves as one side of the field, while the fence serves as the boundaries to the other three sides. The farmer has a total of 1,000 meters of fence available. So first thing you should do for all of these word problems is draw out what you have. So we've got, looks like a river right here. So let's just identify that as our river. So he's one boundary, and it's going to be a rectangular field. So we'll have three sides that enclose this rectangle, with one side being part of the river. If we know that this is our width, this is our length, because this is a rectangle, if this is our length, this is also our length. So that's our setup. That's how we would draw that out. Write an equation in which all three sides are summed up and set equal to 1,000. So we know that L plus W plus L equals 1,000. So we've got to solve in terms of one variable. So they want us to solve for the L variable. So if we add those together, 2L plus W equals 1,000. Subtract the W over, so 2L equals 1,000 minus W. And then we'll divide both sides by 2 and get that L equals 1,000 minus W divided by 2. So the whole purpose of this is to get everything in terms of one variable, so that when we set up our area equation, because this is an area, we're looking to find this area inside. So we know for a rectangle the area is going to be length times width, but we need to have that in terms of one variable. So we know now that because our length is 1,000 minus W over 2, that would be 1,000 minus W over 2 times W equals our area. And that's now our area in terms of one variable. Let's distribute this out a little bit. We know that this 1,000 divided by 2 is 500. So we could even simplify this as 500 minus W over 2 times W equals area. If I distribute that out, that becomes 500W minus W squared over 2 equals our area. Well, if I rearrange that, that's going to look like area equals negative W squared over 2, I'm sorry, there should be W there, plus 500 W. Now, you see this squared right here? Because of that exponent, we know this is going to be one of our quadratics, and this is in standard form. So if I looked at this on a chart, if I was plotting out area in terms of W, area being my substitute for my y-axis, so this is my area, and we know this is a quadratic, and quadratics have the form of a parabola, and this is a negative, so that means that the parabola is going to be opening down. We're going to have something like this. So what am I looking for? I'm looking for maximum area. How do I find the maximum area? That has a very specific identifiable point on a parabola, and that's the vertex. So we're going to be looking for the vertex here. If we were to graph this on the graphing calculator, like they ask us to do in there, we would pull this guy up, go to our y, let's delete these. He is equivalent to negative x squared divided by 2 plus 500x. When I graph that, it's going to be a downward facing parabola. If I can zoom. We'll fit it to zoom. And we'll zoom out. Uh-oh. You can see it's a very large graph. So I have to continue to zoom out, zoom out, zoom out, zoom out. And now we can start to see the characteristics of the graph a little bit better once I zoom out a significant amount of time. If we were going to use the maximum function to identify the vertex, that's one way you can approach it. I am perfectly content with you using the standard form derivation of the vertex, which is going to be taking negative b over 2a and then plugging that value, that negative b over 2a, back into the function. So negative b over 2a, if I take my function, which is negative w squared over 2 plus 500w, that's going to be negative 500, because 500 is our b, divided by our a, our negative, our a, which is 2 times, our a is negative 1/2, right? Couldn't I rewrite this guy instead as negative 1/2 w squared plus that? So this becomes 2 times negative 1/2 is negative 1. Negative 500 divided by negative 1 would be 500. So when our width is 500, our area, we can either plug that back into the equation. So we know that it would be, if I plugged it right back into this equation, 1,000 minus w over 2 times w, that would be 1,000 minus 500, which would be 500 divided by 2 is 250. 250 times 500 would be our area. And that should be 125,000. That's 125,000 square, what are we dealing with? Feet, I believe. Meters, square meters. So what are the dimensions of the field? So the area is maximum. Well, kind of went reverse on this example. They wanted you to potentially use a calculator and find your maximum area by identifying the vertex using the maximum feature for graphing. But because we went this route, we know what the dimensions are going to be. They're going to be that w is 500. And if w is 500, we know that 2L plus w equals 1,000. So if w is 500, L is going to be 1,000 minus w divided by 2. So 1,000 minus 500 divided by 2 is going to be 250. So that's how we're going to solve these equations, is identify what they're looking for, draw it out, set everything up in terms of one variable, and once you notice that we're dealing with a downward facing parabola, identify the vertex.